So based on those observations and other things you can guess by looking at the reaction, what do you think the sign of delta H is? How many people would say delta H is less than 0? How many people think delta H is greater than 0? Good. And delta H is not obvious. You'd need to calculate it. So this is an endothermic reaction because the temperature dropped. Going from reactant to product must be an uphill process in enthalpy. And so we know that delta H is greater than 0. How about delta S? How many people think delta S is less than 0 for this? Oh, is there a question? Sorry. Oh, the temperature of the solution. So the thermometer was put in. It was initially 27 degrees, and then it dropped to 12 degrees after the process occurred, the process being dissolving ammonia nitrate in water. Does that make sense? So the reaction occurred, and as it was occurring, the temperature dropped. So it's endothermic reaction. Delta H is greater than 0. Look good. So for this, how many people think delta S is less than 0? How many people think delta S is greater than 0? And how many people think it's not obvious from anything you've been shown? So there's actually two ways to think about this. One way is that we're going from a solid. This would be approach 1. We're going from a solid to 2 aqueous species. Two things floating around in water is similar to a gas. It's as if two things were floating around in air. So this is a process that's increasing the entropy. Delta S is greater than 0 just by inspection of the reaction. There's another way you can say it, and that is it occurred. So it must be driven by either entropy or enthalpy. It's not enthalpy driven. Because delta H is greater than 0. So the fact that it happened means it must be entropy driven. And in terms of the free energy, the entropy change must be big enough that minus T delta S wins. Because the delta H term is trying to make the reaction not go. If the reaction does go, then delta S must be winning the day.